hi, Simon. Hope you feel better. What's a parabola? What shape? Can you describe the shape?
L shape.
A what letter? A U, maybe a V if it's really close. And it'd be upside down or right side up, right? Based on the direction. Today we're going to start identifying characteristics of quadratic functions. First of all, the vertex of a parabola is the lowest to the highest point it goes. Now, it's obviously the ends of the parabola have arrows, right? So those who go on forever, maybe. But the bottom or the top, where the U is, that part has a stopping point, a specific stopping point. Is this podium in
No. Okay.
All right. The minimum of a function is the least possible value of the function. A maximum would therefore be the greatest. Yeah, the greatest value of a function. It's the y value of the lowest or highest point of the graph. So on a parabola, the minimum or maximum is the y coordinate of the vertex. Minimum or maximum is the y coordinate of the vertex. Take a gamble with me. Is it a minimum value if the parabola goes up, or is it a maximum value if the parabola goes up?
Minimum.
And if the parabola goes down, it's a
Maximum.
So it won't go higher or lower than that point. Okay? So in example 1, Simon, I'm sorry I can't draw this out for you, but it's in your book. In example 1a, we have to give the coordinates of the parabola's vertex. Then give the maximum or minimum value. So the vertex, where does it kind of look at, like it's at? What point is the vertex of A? Taylor?
-4.
Well, what's the ordered pair?
0.
0, -4. That's the vertex. 0, -4. It's an approximate. It's not perfect, but that's about where the V would be. All right? So the minimum of the function can't go any lower than what value?
0, -4, or -4.
-4. Yep. So the vertex is 0, -4. Minimum value is -4. What about B? What's the vertex of that approximate parabola? AJ? Yeah, 2, 5. That's the vertex. So the maximum of this parabola, the highest it'll go, the maximum is
5.
5, because it's 5 spots above the x-axis. Okay? Questions on that first part? Pretty easy. Intercepts, roots, and zeros are related. An x-intercept of the function is the x-coordinate of the point where the graph of the equation intersects the x-axis. The 0 is the value that makes the y value 0. Because y equals 0 for every value of x on the x-axis, the zeros of a function are the same as the x-axis. So in this equation here, this parabola here, I'll draw you a rough sketch of it. 10, 15, 1, 2, 3, 4, 5, Okay, so on this graph, the parabola's vertex is what point? Can you estimate where the vertex is? 2a? 1, 4. So that's approximately in this range. And this is a parabola that opens up or down? Down. So this makes this a maximum or a minimum?
Maximum.
Maximum, because it can't go any higher than that, right? So the maximum of this graph is
4.
4. Can't go any higher than that. Okay? The x-intercepts in the book, and kind of mine, appear to be what places? Where is it across the x-axis? There's 2 spots. The book's probably going to give you a more clear picture.
3 and -1.
Yeah. Do you see that? At 3 and -1, that's where it crosses the x-axis. That's where it breaks this plane. Actually, mine's not that bad. Probably 2.9 and like 0.5. So 3 and -1 is where it crosses the x-axis. All right? So what you have to do is substitute these pairs into the equation. And the equation they give you in the book, f of x equals -x squared plus 2x plus 3. Okay, and you gave me the places where it crosses, so that's -1, 0, and 3, 0. So plug these in. F of x is what value? Jeremy? What value is the f of x? The y. So in this case, you have 0 equals -1 squared plus 2 times -1 plus 3. -1 squared is 1. That becomes -1 plus -2 plus 3. Does that equal 0? So that is a 0 of the function. Then plug the other one in. Okay? You've got same process for 3 and 0. And you'll find out that that works. So the zeros of this function, are -1 and 3. Those are your two zeros. Okay? That's how you answer that. The zeros are -1 and +3. What about example B? Where does it look like it crosses the x-axis? Taylor.
Like at the vertex, which is at -2.
Right. So here's something to keep in mind. How many places can a parabola cross the x-axis? 2, 1, or 0. So how many zeros are you ever going to find? 2, or 1, or 0. All right? In example C, does it cross the x-axis anywhere? So what's the zeros of that function?
0.
There are none, right? There's no zeros of that function. Okay? Example 3, finding the axis of symmetry. Think of the axis of symmetry like a hot dog bun. Okay? Where do you put the hot dog? On the bottom of the bun? On the side of the bun?
Sometimes.
You could. You might think you're a little odd. Most people put it in the middle of the bun. That's your axis of symmetry. That's where your hot dog bun folds up. So to find the axis of symmetry, when there is 1, 0, which of those graphs, A or B, has 1, 0? AJ? A. What is the x-axis, the 0 there? What's the point? What's the 0 there? Where's it cross? Kayla?
-4.5.
-4.5. So when there's one point that touches the x-axis, your line of symmetry is what? You said -4.5. Is that y equals or is that x equals? X equals -1.5. That is your axis of symmetry. Now if there's 2 points, you have to take the average of it. So on example B, what two zeros are there?
-3 and 5.
-3 and 5. So you add those two together, divide by 2. What's -3 plus 5?
2.
Divided by 2 is?
1.
So what's the axis of symmetry?
1.
X equals 1. Okay? When it doesn't cross the x-axis, well here, I'll show you the symmetry formula. Okay? Symmetry formula. This is found in your book on page 588. So you have, what's a quadratic function? Y equals ax squared plus wow, only Nicole and Jeremy know that. Okay? The axis of symmetry is x equals -b over 2a. That might help you out. The axis of symmetry using this formula. Okay? So you've got y equals x squared plus 6x plus 5. So there's two ways to find the axis of symmetry. First way is graph it, find the zeros, either split the difference or use there. The other way is using this formula. So you have x equals negative, what's your b value? 6. What's your a value?
5.
1.
No,
1. So x equals -6 divided by 2. -3.
3.
Okay, you could have plotted that, and you would have found it would have worked too. That's up to you. Okay? All right, let's look at the lesson practice. Simon, you can do the lesson practice with us if you want. What are the coordinates of the vertex in example A? Taylor.
-1, -4.
-1,
-4.
-4. Okay. Is this a maximum or a minimum?
Maximum.
Maximum of -4. And then it says to give the value and domain. The domain is all real numbers. All real numbers. The range, all real numbers less than or equal to -4. Remember which value is domain? X or Y?
X is domain.
X is domain. So your X is all real numbers. Your range, all real numbers less than or equal to -4. Right? So your maximum or minimum is your range value. What about B? What's your vertex? Nicole? 5, -3. Do you have a maximum or a minimum? What is it? -3. Your domain is all real numbers. Your range is all real numbers greater than or equal to -3. Very good.
Is domain always all real numbers?
Yeah. Because you can put anything you want in for the domain.
You can always plug
Any number in for the domain, and it'll spit out your Y value. Okay? C. What are the zeros of that function? First of all, how many zeros does that function C have? 1. What is it? 6. What about D? How many zeros are there?
2.
2. What are they?
-3 and let's say
8. I mean 7.
It's actually -3 and -9.
-9.
But you would have counted that out in your homework. E? How many zeros?
1.
0.
No,
None.
0, 0.
None.
That's what I meant.
F, what's the axis of symmetry? Remember, if there's 2 points, you have to add them up and divide by 2. So x equals, Taylor? Right. And what about G? Nicole? -2.5. Okay? Using this formula here, what's the axis of symmetry for H? X equals... Use this formula here. Kylie. Yep, x equals -2. What about G?
Mean I.
F, G. Oh yeah, H. I can say.
It's -1.
3. X equals 3. See how to do this? Any questions? Little fuzzy maybe, but you'll get it. You can always do these on your calculator. Simon, we hope you feel better.